Okay, another question about this capacitor, resistor, and battery circuit, again after a very long time. So what we know after a long time is that the current through the capacitors is zero when fully charged. And in order to solve this problem, what we're going to need to do is actually figure out how the circuit looks after a long time. So let me just relabel the plus and minus sides here. We have the current going up here, plus side first, then the minus side. And that same current is going to be going, since we have here, this is 0 for all these capacitor lines, that same current's going to come down through R3 and then come around. The switches have been closed for a long time, like that. So I can do an outer loop here, my Kirchhoff's voltage loop, sort of an outer loop around like this. If I do that, I'll get minus the battery voltage plus I times R1 plus I times R3, and then I'm back where I started, so it's equal to 0. And again, I know that the current here through R1 and R3 is the same because the currents through C1, C2, and C3 are 0 at this time. So I can simply solve this, and I find out that the current, after a long time, that goes through the battery and through R3 is just equal to the battery voltage divided by R1 plus R3. In this case, it's equal to 18 volts divided by 10 plus 30, or 40 ohms. Okay, so now I know what the current is. It's going through there. It didn't ask me about the current. It asked me for the charge on capacitor 2, but I can do another loop here and figure out the charge on capacitor 2. Let me just write this as minus, plus and minus. For when it was charging, I'd have the positive sign there. And I can do a loop right around here as follows. If I do that, I would get minus I times R3 is going plus the voltage across the capacitor, and I'm back where I started, it's equal to 0. So the voltage across the capacitor is just equal to I times R3. And so we already know what I is here, so it's just going to be 18 divided by 40, and R3 was 30, I believe, yes. R3 is times 30 ohms. That's the voltage across the capacitor, so the charge on the capacitor is just equal to the capacitance times the voltage across it, so this is just going to be equal to the 30 microfarads times my 18 over 40 times 30, and when I plug that all into my calculator, I do indeed get 270 microcoulombs. Oops, sorry about that. I see I made a mistake here. That does not give me the 270 microcoulombs when I plugged it in my calculator. The reason is this was supposed to be capacitor 2 that we wanted the voltage on, and so this needs to be multiplied by 20. Sorry about that mistake. Now it does actually work.